Okay, so this is the third video going over Michael's exam one. Okay, so then 16 was the next one. You had a score of 0.67 on this, and
Yeah.
I don't know what the heck you wrote the right answer here.
That's honest. When I did that, I was like, I remember this because this was literally on the last. It was either the last homework or the last quiz. I was like, I remember this exact one because my tutor yelled at me about it. But I was like, because I was like, I remember, I completely remember that the first answer is no because it's oscillating and it
Mm-hmm.
can't. It's just going to keep going, and if it ever hits a -2, it's going to be undefined. It won't be
Right.
any number. And then when I was looking at that, I was like, well, it stays on 0, but I was like, doesn't it go to infinity? And that's
So
what I was like,
we only care what it looks like it's going to. We don't care
okay,
what exactly happens at -2. We only care what it
okay,
looks like it's doing. You remember
okay,
that. So over here, yeah, it looks like, I don't know, it can't even decide. The closer it gets to -2, it's still wildly oscillating. I don't know where it's going. This one, you can clearly see it's staying on, and you wrote that. So the
yeah,
answer should have just been 0.
yeah.
But you wrote infinity, so I
I
don't
don't.
know.
I
But
just get. I
yeah,
just. The more I look at something, especially with math, I just second guess, and I'm like, oh, that can't be right. That's too simple.
okay. But anyways, I increased your score from
Okay.
0.67 to 0.95 because it seemed to me like you knew what you were doing, but then yeah, you second guessed yourself probably. But.
Okay.
All right, 17 you had fully correct already.
Okay.
18 you wrote the important things that you need here, but then you didn't do it.
Yeah.
Right.
This made me kick myself because when I first looked at it, I was like, oh, I remember these exact ones because basically whatever the coefficient is in the numerator for x is the number. And I remember because it was like 3 or 4 the exact same thing, and I saw that and I was like, yeah. And then when I looked at tangent, I was like, oh well, I only remember it being with a sine or a cosine. So like with a tangent, you have to break down the tangent first,
You do.
and then
Yeah. So you have to write that tangent of 5x as sine of 5x over cosine of 5x.
yeah,
Just like you were starting to say here. Because you have to break it down to where you get sine of something over the same something, right? So the problem is I only have an x in the denominator, and so the 5x up here, that also has to be a 5x down here because that's where, right, sine of theta has to be in the denominator down here. So you needed 5x. So you just force that to be a 5x, which means you got to put a 5 in the numerator so they cancel. That's why it comes out to be that 5. Because then
okay,
sine of 5x over 5x, that limit as x goes to 0 becomes 1. And then as x goes to 0 for the cosine piece, you just plug in cosine of 0, which is 1. So that's 1, and then you just get the answer to be 5. Yeah.
yeah,
So you were right. You know, if you don't show me any work, and you know that the answer is just 5 and you write it, I mean, I'm not going to take points off for that, right? If you got the right answer, I'm not going to say, hey, you didn't show me your work. I'm going to take points
yeah,
off. But since you didn't get the right answer, I had to try to look to see. And you did, you know, it wasn't like you were showing me here that you knew what to use. You just didn't know how to use it. So I went from 0 to 0.33
okay,
because you have to show me that you knew how to use it too. But
okay,
20, this was a very silly, I mean, you did the right thing. You factored the denominator, but then that would
yeah,
be that x can't be 2 or 3, and you wrote -2 or -3.
yeah. I didn't do like x minus 2 equals 0,
Right.
instead of equals 0. Yeah, I
Yeah.
see it when I saw that once I got like my math lab answer right, and I saw that, I was like, crap, and I was like I never set them equal to 0. And I was like,
But that's okay because that's you still totally knew what you were doing. You knew you had the
yeah,
denominator of this. You know these had to equal 0. So I knew that you were thinking correctly. And with x not being -3 or -2, if that was correct, your answer would have been correct because you put it in the correct
yeah,
interval notation and you had it correct. But it's just it should have been 2 and 3 instead of -3 and -2.
yeah.
But so anyways, your score went from 0 to 0.9 out of 1 because I felt like you knew what you were
Yeah.
doing there. But and 0.9 out of 1, that's raising your percentage grade almost 3%.
Yeah.
You know,
Yeah.
so because each problem's worth about 3.3% ish.
Okay.
Okay, so then 21. 21, your only problem, well, first of all, you did say that it was, the function is not continuous. The thing is, if the function was not continuous at pi over 3, you would not be able to just plug in pi over 3 in here. The whole point of being able to just plug in pi over 3 is that the function has to be continuous to be able to bring the limit inside the radical sign. So that's why you had to have this one. The function is continuous. You chose this one. But then when you evaluated it, secant squared is 1 over cosine squared. For some reason, you thought it was tangent.
Oh, okay.
Right? I think now the derivative of tangent is secant squared, but that's not. So they do have.
Yeah, and that's what I was thinking. You could just go backwards and forward.
No. Yeah. What is so secant of x is 1 over cosine,
Okay.
right? So secant squared would be 1 over cosine squared. So you had to evaluate cosine down here, not tangent.
Okay.
So it ends up once you do that, it comes out to be square root of 25, which is 5.
Okay.
So anyways, but because you were doing a lot of the work here, I could see that you knew pretty much how to evaluate this, except not what secant squared was. I still went from 0 to 0.5.
Okay. Yeah, I mean, every bit helps.
Yeah, and the point here is that it's continuous at x equals pi over 3. Remember that. That's why we could do it. All right, 22. 22, you just didn't have anything. You wrote the number, but this is one where if I'm taking the limit as x goes to infinity, I just need to look at the highest power of x in both the numerator and the denominator. So
That's what I remember. Because, like, this one was bothering me because I remembered when I worked with my tutor, he was telling me about this, and I couldn't remember because he told me if it's a really, really big negative exponent, then it means something.
well, if it's a big negative exponent, that's the same as 1 divided by x to the 8th, right?
Yeah.
Now, this is x to the 1/2. 1/2 is bigger than negative 8, right?
Yeah.
So you would only keep this. See, like, look over here. If I'm using the highest power rule, can you see my cursor over here on this? Or is that?
Where is it?
I'm on the.
Oh, yeah.
I'm on this where I wrote it out for you.
Yeah.
So by using the highest power rule, you just look at the highest power in the numerator. This is x to the 1/2. This is x to the -8. So 1/2 is bigger than -8. So that's the one I keep.
Okay.
Down here, this is x to the 1. There is no x here, so I don't worry about that. That's like x to the 0, if you want to think of it that way. But it's, 1 would be bigger than 0 if you think of it that way. But so you just keep the 6x, and then you simplify that. The 6's cancel, and the square root of x divided by x leaves just a square root of x in the numerator.
Okay.
I mean the denominator. So it's just 1 over a big, big number, which is 0.
Okay.
And you wrote, I don't know, you wrote minus infinity, but it's not. I needed to see. There's no way for me to know what you were thinking by just looking at that answer.
Yeah, I get that as well.
All right, and then 23, all correct on your own. 24, all these limits, they went crazy on you. And I think, so this problem, I couldn't increase the score because you had this, and then you looked like you were trying to take the derivative of the top divided by the derivative of the bottom, but that's not a derivative anyways. Remember, you have to use the quotient rule if you're taking derivatives of a quotient.
Yeah.
So, but that doesn't help you do the limit anyway. So when you're looking at, now you might have been thinking L'Hopital's rule if you got indeterminate. Yeah. If you were, then you do take the derivative of the top divided by the derivative of the bottom.
Yeah.
Right? But technically, L'Hopital's rule is a top 2 thing. So anyways, you actually needed to evaluate these limits. So when you plug in 0 with a little positive sign, that means a really, really, really tiny number, right? Is what that means. You don't ever actually plug in exactly 0. Now, if you plugged in exactly 0, we get 24. But this is 0, this is 0, or close to 0, this is close to 0. So in the limit, this gets closer and closer to 24. Now this guy, that's 0 minus 0, right? If I plug in 0, which would be 0. So 24 divided by 0 is undefined, but you got to think more precisely about what kind of close to 0 is this. So like, even if I plugged in like 0.1, something really close to 0 but positive, right? 0.1 cubed is just 0.001. You move the decimal over 3. 0.1 squared is 0.01. Minus 6 times 0.01 is minus 0.06. So 0.001 minus 0.06 is a negative number. It's a tiny negative number. So 24 divided by something really tiny but negative is actually negative infinity, not. And then let's see what you put. I'm trying to remember. 0 even. So there's no work, so I couldn't really.
Yeah, it's fine. Yeah, I did not.
Okay.
Yeah.
Now for the 6 and this, from the 6 to the right and the 6 to the left, these two guys, B and C, the work would be the same for both.
Okay.
So the first thing you do is you plug in 6 and you would get 0 over 0. Well, that means I want to factor and try to cancel. So the numerator is x minus 4 times x minus 6. And the denominator, you can factor out an x squared times x minus 6. Now the x minus 6 is canceled, and you just plug in your 6. And you get 2 over 36, which is 1/18.
Okay.
And the same work for C. It's the exact same work. And then that means that D would be the exact same answer, because if you come from the right or you come from the left and they're the same, then the two-sided limit's the same.
Okay.
And then to answer E, you had to go back and think, well, I need the answer for A, but I need it to be x approaching 0 from the left, so I have to look at that first. But it comes out to be the same result.
Okay.
You still get negative infinity, which means the two-sided limit would also be negative infinity.
Okay.
Okay. So that's 24. Now 25, you got all right on your own. So we'll look at that. 26, again, I couldn't increase the score because he said nothing there for me, and it's the same exact problem as we had before.
Yeah.
It's just a little bit harder because you got x squared and x in it.
Okay.
But it's the same as f of x plus h minus f of x over h. Take the limit as h goes to 0. You just have to work this algebra out.
Yeah.
So we'll look through that. But
I will.
again, I would tell you, if you got this a problem on the final, don't use this. Use rules.
Yeah. Do the derivative.
Right, because the derivative of this is going to be what? 6x plus 5?
Yeah.
So you plug in negative 2, you get 6x is negative 12, plus 5 is negative 7, boom, you're done. Right?
Yeah. Okay. And then,
Yeah. So when you get to the final, don't do it this way. Just use the rules. Okay. 27, you got all right on your own again. Let's see, I'm at minute 12:45. I think I got time here. So 28. I actually should have shown you the limit rule way, but I said, nah, he doesn't have to do that for this again. So I'm just going to remind him about the quotient rule, which you probably know now. Technically, you should have done this using the limit as h approaches 0. You get a t plus h here. You get a t plus, it's kind of a hard algebra problem.
Yeah.
So I said, I'm not going to even show him that. I'm going to remind him what the quotient rule is.
Okay.
So remember, the quotient rule is low d high minus high d low over low squared.
Okay.
So you work that out. You get this 8 survives over that. So just try that. Make sure you understand it. But use the quotient rule. Don't use the limit definition anymore. Okay?
Okay.
And then on 29... I looked at it anyway, even though you didn't show me anything, but so the graph of the derivative of the function, what you have to think about when you're doing this, since you chose something that's not even close to the right answer, I didn't feel like I could.
Yeah, I mean, it was 300% a guess.
Okay.
Yeah.
So, but just think about what is the slope of the tangent line. That's what the derivative is, right? It's always the slope of the tangent line. So notice that it's negative here until we get to right about here. And then it's 0, but then it's still negative, right? And then it gets big negative. So it's just this guy. It's always negative.
Oh,
the slope of the tangent line is always negative. That's all you had to think here. Slope of the tangent line, always negative.
Okay.
One point it touches 0, right here where there's a flat horizontal tangent line.
Okay.
But other than that, the slope of the tangent line is always a negative slope. So that's that guy.
Could you argue that it could be D because it's always negative?
No, because it's positive up here, right?
So okay.
You're looking at just the sign, the SIGN of it, not the slope of it itself. You're not looking at the slope of this graph. You're looking at the slope of this graph and making that be down here.
You got 15 seconds.
Yeah, so I'm going to stop this now.
Yeah.
Okay, but I think we've covered everything because you got.
Yeah,